So now let's discuss a question about counting subsets and functions, and this will be something that's going to come up later in the course. The first question is, how many functions are there from a set with 100 elements to the set 0, 1? So this is a fact that we may just know at this point. Certainly something we've gone over before. On Stack Exchange, I can say, how many functions exist between the set 1, 2, ... up to n, and the set 1, 2. And that's going to work awesome. The answer that I get to this question is the number of functions from a set x to another set y is given by y raised to the x, since each element in the set has y choices. So if I can identify here that my x has 100 elements, the size of x is 100, and y is equal to 0, 1, so the size of y is equal to 2, that will tell me pretty quickly that the correct answer to this question is 2 to the 100. The next question is, how many subsets does a set with 100 elements have? And I could look it up again, but I think it's better to think about this as a product principle problem. So even though 100 is a very large number, if I want to make a subset of a set with 100 elements, I can break this up into a number of concrete tasks that I need to perform. And I'm going to emphasize again, I think that counting problems are best viewed as algorithm problems, as thinking about the different things that can happen when you actually physically go to do the thing. So task 1, choose whether or not to include the first element. There are 2 choices. Task 2, same thing. Choose whether or not to include the second element. There are 2 choices. There are going to be 100 total tasks. So there are going to be 100 total tasks here, and each task has 2 choices. 100 tasks, each task has 2 ways. It's 2 times 2 times 2, 100 times. Write as the product from t equals 1 to 102 each time. Or the answer that you're probably most familiar with here is 2 to the 100. But notice something cool with me. Both 4a and 4b have the same answer. They're both 2 to the 100. Is that a coincidence? Why is that? There's actually a correspondence between functions and subsets. So we can use that correspondence. There's something called an indicator function. An indicator function is an indicator function for a subset. Your function I of x is equal to 0 if x is not in the subset. I of x is equal to 1 if x is in the subset. And this is a really cool way to get at some of these problems. We'll talk about it more later, but I just want to go ahead and bring it up as an idea. And I know some of you will be curious and want to get more into this. So, I mean, the Wikipedia page for it is very readable. Just look up indicator functions. It's also called the characteristic function. And it's also, people use the notation 1 sub a for this. So we'll talk about this more. It's also known as a Boolean predicate function. The Dirichlet function is an example of an indicator function. And there's Iverson bracket notation, which I also use Knuth notation. So just this one simple question has a lot going on with it. And it's supposed to kind of prod you to just think a little bit about the fact, why are these 2 numbers the same? When we go to count them, both counting arguments can use product principle. And so there's this correspondence.